All right, how we doing, everyone? Doing good. All right, welcome to 420 Lab. This is going to be Electronics 2, and the way we're going to be doing this is going to be called our Cadence Virtuoso Lab. The goal of this lab is we're going to be learning how to use Cadence as a tool so that you can use a theory. Everyone is enrolled in Dr. Mingzu's 420 lecture, correct? Who Okay, let me see. Let me ask this question. Who isn't taking that lecture but has taken Dr. Baker's 420? Any question? No, no, no. Good. All right, perfect. So no one here has taken Dr. Baker's 420, right? Perfect. Anyways, so that means this is going to be a different format because I think the way that Dr. R. Jacob Baker has taught it in the past was he was using LT Spice, and the goal was to design op amps in the lab. So you would have to use LT Spice to physically create these op amps. Dr. Ming Zhu has taken the different approach as he is our new electronics professor. He's taken the approach of making our circuits classes more modern, more up to date. So that in that case, we're using Cadence for 420 for the first time. So you guys are more focused on learning the theory and then using the tools in the lab. Is that good with everybody? So what I'm saying in this class is the whole point of this lab. I think your final project is going to be do something. What do you call it? We're probably going to simulate, design, layout a what do you call it? Maybe some type of amplifier. It's probably going to be something simple, not too hard, because the hardest part of this class is the tool. And I've had a few emails already. Like I can't even get to the login page. I'm like, so I need to make sure is caught up with it. Okay, is that good? So this is gonna be a chill lab. It's more understanding the tool. Cadence Virtuoso. I'll just take you to their web page. Cadence Virtuoso. Yes, there we go. This is an application that a lot of the entire industry uses for IC design. So you're literally touching, I think it's 80,000 or $100,000 a year that we're paying for this software. So it's actually that's for commercial. We get a student educational discount, so it's a little better for us. But this just like your I think like AutoCAD or Autodesk or those other applications that you guys use around the labs, even MATLAB, I think like it's like $3,000 a year, but you guys get like a heavy discount, right? Take advantage of this lab. This is probably the only lab that you'll ever experience this tool, so I highly encourage practicing, learning any techniques, because this class, not just this class, this application can get you into companies such as Micron. I had a friend go into AMD. There's NVIDIA. There's Apple. All those big high tech companies in Silicon Valley, in Texas, and I think Arizona is opening up some positions down there for IC design engineers. Boise, Idaho, definitely one of their central hubs there. I think even their Qualcomm too. So a lot of these companies use this program. Even smaller companies. I'll tell you one of them that I worked for, Freedom Photonics. Actually, that's what I have this chip right here. This is a special project that me and a small team of engineers were able to build here at the university. We were contracted by this company in Santa Barbara, a small company of I think like 100 people, to design this entire chip. So we were literally built on PhDs, masters, and I think I did this while I was an undergraduate. Yes, so literally with the knowledge that you obtain from Cadence, you can like okay, I'll show you some stuff. Okay, this is scary. Okay, looking at this right now it's a scary thing. I'm not saying oh your final project is this. No, no. Your final project may be as simple as something like this. Let me. No, I don't like this picture. Hold up. Use this other picture. There we go. The downloaded picture. Your final project may be something like those are inverters. Uh, that right there's a fat transistor. I think your project may be something as simple as maybe laying something out like this. If you think this is complicated, this actually is one channel, one circuit right here, one fat circuit. This is like one circuit here, two, three, four. You see the stages, right? And if you want to make it multiple channels, you just copy paste. That's how they do it in the industry. You just copy paste the same design. It's pretty cool. Um, think this is one of my messier layouts. Not too bad. It's not too bad. But anyways, I think we're probably going to tackle, we might even just reproduce the project I was doing. Our first project is going to be this little guy. What does that look like? Does anyone know? This right here is an inverter. And I think what happened here is we're taking a signal. It's coming from somewhere. Where is this coming from? This is a metal wire, by the way. Have you guys gotten familiar? Has he shown you the actual layout versions? Like colors of the actual application? No? Okay, this is great. So I'm really showing you a lot of new things right now. So let me show you. This is a digital input. Okay, it's a digital output. Here's a buffer. So we're trying to buff some juice into this little signal right here. It's going a long distance away, so there's going to be noise, okay? I'm not going to go crazy on noise, but anyways, this right here is your first stage is an inverter, okay? So I think the goal, maybe it might be like a 2-week assignment or 3, depends on how the class is doing. We're probably going to be designing an inverter. Maybe it might be designing a buffer. And then I might be asking you, can you tell me the rise, the fall times, and just simulate it, okay? So then I can just check you off and say, congratulations, you know how to do it. The other thing in this class is it's a lot of memorization. So you're learning a new piece of software, and that's same thing with, like, if you remember taking 360 where you had to learn MATLAB for the first time, and that pain was like, it was a lot, okay? This is going to be the same kind of refresh with a different application, Cadence, even learning the simulator. I think the simulator is like HSpice or something like that. I forget what it is. I'll show you what that is. And then the actual schematic editor or layout editor, which is, I think, forget what it's called. Not Allegro, but it's Virtuoso. But anyways, you got what do you call it? Schematic. You have the symbol design, and then you have the layout. And I want you guys being able to design, simulate, and produce chips, okay? Little circuits like that. And maybe the final project, I'll create a mock plate, and then I'll get everyone's circuits, and we'll put it inside like some pad frame, some mimic pad frame, okay? Is that good? Any questions about how this class might go? Oh yeah, the other question is, are we going to have meetings every week? So I could, but I'll tell you this, insomnia sucks, and you can't sleep, and you got to come early at 8:30 in the morning. So would you guys like it if there's every other week, like we meet, or I just send you guys emails or updates? Or do you guys want me to just still come every Wednesday and we just do these recorded videos? Be like, hey, any questions, comments, concerns? Not that bad. Or I'll just send you guys a file and be like, just copy this. Is that good with everybody? I'll keep you guys posted, okay? Because this lab, let me just check. I'm gonna show you guys some private stuff. Let me see. Mail. Let me see. Mingzhu. See where. Okay, 420. There you go. 420 intended schedule. Now screw this. I told them we're not doing anything crazy. You see, this is what he wanted me to do, but I said, why are we going to focus on what do you call it? Hardware implementation, like the NPMs that we have in the lab, and then I'm going to brute force you guys to learn Cadence. That's too stressful. I don't want to put you guys under that stress. So we're just going to do all software-based stuff. It's going to be not that bad, okay? We're not doing anything physical, okay? This is a very expensive piece of software, and I think that is a luxury. I'll tell you this. I have first used Cadence, I think, back in 2018 when I took, was it 2019. Yeah, 2019. I took 420, but that was LT Spice, and we had to design like a 2-stage op amp. It was insane. And then 421, we designed a band gap, or was it a band gap? Let me show you guys some stuff. That's this. Oh, come on, go back. Come on. Yeah, I think this is one of the, what do you call it, 421 projects that we did. But Dr. Mingzhu has changed the 420 course to where you're doing. Who's taking 421? How was that? Not that bad, right? How do you do the labs?
It was a lot of cadence.
Just Cadence,
Um,
right?
mostly, yeah.
Yeah, and what was your final project?
It was whatever we wanted. Like I did a Smith trigger.
Oh, that's great. I'd like to see that layout. You guys laid out, right?
Yeah.
Oh, perfect. Anyways, but yeah, this is something we did. But you guys used, I think it was like Synopsys, correct? To
Yeah.
code it and use the RTL or what do you call it, Verilog? Yeah, so I need to learn that too. Anyways, you should in the actual industry. There's two types of engineers. You have their digital layout engineers and the analog version. The digital ones, there's if you look at like the Intel chips, there's like I'm just saying this like 64, 128, 256 bus lines. That's a lot of lines, and for you to hand draw it, it's not the right way. The right way you do it in the industry is you just type it, code it, and press enter. It compiles. Right? Is that how it works? Is that how you guys got your projects done? How many lines did you guys have? Like 8 bus line?
Like the files were given to us.
Oh, really?
But yeah.
Oh, wow. Okay, so in this case, no. The other way, and that's why it was kind of brute force, is the what do you call it? The analog way. There's very few analog engineers, but if you get really precise into this field, it's a really good paying job. I'll promise you that. But digital design is also pretty good too, because all you do is just Verilog and you're pretty much good to go. Here, you're not doing coding; you're just drawing shapes. Like literally, this is my. I think which one's my first layout? Yeah, this was my first layout, I think. And then right here, I think you have some inverters. Yeah, this right here is an inverter. I think this is NMOS. This is a PMOS. This green shape is an N-well, right? Have you guys learned about the N-well yet in the class? No? Oh gosh, I'm gonna have to teach you a lot now, huh? So that's what's scaring me right now. Anyways, this right here is an inverter. Here's an NMOS. Here's a PMOS. So what does that mean right here? This is also transistors, right? But this is a 1, 2, 3, 4. We have what do you call it? Oh, this is one giant inverter, but you can do finger splits. I'll show you guys that later. Yeah, this is one giant inverter. So, have you seen the transistors in class, right? Or in the labs? Like I think it's what do you call it? Was it the ZVP to something? ZVP PMOS. I'm just gonna say this. Like one of these guys right here, or something like that, right? There's a way to buff your what do you call it? Your transistor, and that's if you put them in parallel. Have you? What else have you talked in the lecture? I'm trying not to push too hard. What else did you guys learn in the lecture? What did he go over? Yes.
He's just reviewing a lot of 320 stuff right now.
320 stuff,
Yeah.
such as like BJTs,
Yeah, BJTs,
MOSFETs. So you guys don't know how to increase the width of a MOSFET yet using fingers? All right. I think I got a lot of hauling to do in this lab. But anyways, there's lots of things you can do with Cadence. In 320, you're just given a strong, like just hard number. It's basically deal with this component. You're kind of there, right? But in 420, okay, in this class, you're actually designing your actual transistors. So it sounds crazy, but yes, you can create any type of transistor in this project. So, like this right here, if I were to show you a good example, like this right here is a really tiny transistor. This right here is an NMOS. This is a PMOS, and you can size them up pretty differently. It's not that bad. But anyways, I can't figure out. Let me see. Go back to here, SPS layout. This is a boost power supply, if you guys know what that is. It basically takes a voltage and goes from like 5 volts to 9 volts, boosts the voltage, right? But you burn more current. And this right here are some types of resistors right here. These are diff pairs. And these are more transistors. So when I'm talking about transistors, and I'll tell you this, and you're going to be seeing this question many times. Let me see if I can find a good transistor. Sorry, me see. Or anyways, here's a transistor, okay? This right here is a PMOS, okay? And this PMOS has 2 fingers or 2 gates or 2 transistors, okay? So in this process, if you see like a funny like bright line like this is known as like the gate of a transistor. And this gate basically says, oh, if I were to do something like this, let me just show you. NMOS, PMOS, layout, or cross section. There we go. Images. Something like this. There we go. We got the polysilicon that's on top of that, right? And then we got the 2 diffusion layers. So if this was like a, what do you call it, a NMOS, right? We're going to have a P substrate, okay? P substrate, right? So that means these diffusion areas are going to be N-doped. N-doped. So P sub and N-doped, okay? So that will create our NMOS, all right? Because it's an N channel, right? Does anyone understand what when I say N channel transistor? Right? No, not yet? It's going to be a lot of things to teach y'all. Anyways, let me see if this is a good picture. Is this a good picture? Can you see that? So you see this piece. Let me just click on it. I don't like that. Let's see. Polysilicon. Oh, it's the same page. Ooh, cute. Structure of the NMOS, okay? So in industry, you have 2 types of substrates. You have the P-type substrate and there's an N-type substrate. But I think generally I've never seen an N-type substrate in my entire, I think 5 or 6 years of working with IC design. Typically, it's always a P sub, okay? You're going to just be given some big fat like piece of silicon doped with P-type material, okay? And P-type material, let's see, has an extra hole. So that means, what do you call it? If it has an extra hole, let me see your periodic table. There we go. Got to teach you guys the chemistry. Anyways, silicon. If we have 1 extra electron, we have phosphorus. We have 1 less electron, we have boron. Is that correct? Did I pass my chemistry exam? Anyways, let me just verify. Phosphorus P-type. Yep. Phosphorus is a P-type. Yep. P-type semiconductor because it has an extra electron. P-type? Wait, hold up. P-type? Hold up. Let's see. Uses dopant for N-type. Wait, hold up. Black phosphorus. Wait, hold up. Give me a second. Maybe I'm mixing my things up. This is an extra electron. This is 1 less electron. All right? So this is what you have to use for your N-type because you need extra electrons, and this is what you need. So let me see. P-type semiconductor, an N-type semiconductor. Let me see. There we go. So yeah, these are your 2 types of substrates that you can definitely experience in this class. Well, we're only going to be experiencing the P-type. Anyways, let me see. N-type semiconductors have an excess of electrons. Okay. I was just refreshing my mind. Anyways, let me go back to what I was trying to show you guys. So there's a bunch of electrons in this N plus, okay, right? Is that understood with everybody? Okay, so you have a bunch of electrons right here and they're just chilling around. There's a way where you can create a voltage right here. If I were to put like a positive voltage right here, right, at this gate, correct? This substrate is going to have some type of electrons, right? That's just existing in this P-type substrate. If I put so much pressure onto this, like a bunch of positive charge, I'm going to carry some electrons into this, creating a bridge, all right? It's a bridge of electrons, and then you have a point where this and this is connected by some funny pseudo wire. Let me see if I can show you what that is. N-channel MOSFET cross section. There we go. Is this a good picture? want to say, yeah, I think this is it, depletion. I think that's a good picture. Let me see, N-type channel. Literally, it just creates this bridge right here so that it acts like a wire, okay? So if this is N-type and this is N-type connected by an N-channel bridge, right? It's one wire. Isn't that crazy how, like, silicon itself, you can create pseudo wires just by manipulating charges? So that's exactly what you're going to be trying to, like, replicate. But I'm trying to give you this, like, behind the scenes knowledge, because layout isn't just like I'm just going to draw a shape and hope it does something. But no, you're magically going to be, like, understanding, like, what's going on. It's not as confusing as it thinks. And I don't know what else Dr. Zhu is going to be teaching you guys, but I'm going to be showing you guys how to use this tool. So anyways, with that, let's see. But yeah, I think the first project we're probably going to do is probably lay me out a inverter. Okay, here's an inverter, correct? And then how do you create a buffer? You just put two inverters together, right? Right? Is that understood? So maybe like 2 weeks I'll make you guys. I think in terms of the lab reports themselves, I think what we're gonna do is it's gonna be a document for your future use. I'll tell you this: I've created some documents myself, and I'll show you this resource. Let's see. No, that's that one. David. Let me see. David's webpage. Projects. Well, that's a noise shaping modulator. High speed amplifier. Anyways, let me see. Did I do anything right here? Actually, oh, don't have that. What the heck? Anyways, what about this one? No, I don't have that one either. Let me show you this picture. This is my second layout once I started practicing Cadence a lot. You start having more professional things. You can start seeing there's more organization. You see these right here. These are called our power rails, right? Signal rails, power rails. Apparently, the way the industry works is you have to have like a frame, create a frame so that your piece, when let's just say you're doing your own piece, someone says, hey, we're all creating a project, make it like 100 micron tall, and that's pretty much it, because we're just going to create it like Lego pieces, okay? That's literally all it is. It's just Lego pieces, okay? So if I wanted to do a project where everyone's just connecting each other's like circuits, you guys are going to have like a definitive border, and that's where this layout came to play, where literally it's just Lego pieces that just stick together, okay? So all you do is just copy, paste, make sure everything goes through. Oh yeah, these are special resistors. You can cut them with a laser to get the perfect attenuation. These are pad frames that are made out of glass, followed by this big fat top metal. And then, what do you call it? And then, yeah, you see these big rails right here. This is actually proprietary information that the company was able to give us. This might carry like VDD. This is a VSS. This might be another digital VDD or something like that. So there's digital VDDs, analog VDDs, the ground versions of them too, and then you have a substrate. Okay, that's another thing I gotta show you too. So do you guys know what the body of the transistor is? Have you talked about that in your classes? The body, the substrate, how to connect to the fourth pin? No? Okay. I think we might just go over, LT Spice before we go anything crazy, because I want to talk about that too. And why am I not charging my laptop? You guys have a charger there before my thing dies? Let me see. How's everyone's morning?
Yeah, right
Sleepy?
here.
Thanks, Dave. Anyways, let me just show you this. Or should I show by example? Actually, no, let me see. What do you call it? NMOS body terminal layout. There you go. Is this a good one? Here's a simple schematic. Have you seen something like this? Not yet? No? Maybe I'll show you guys later. Because I really want to show you guys this. Oh, there. Oh, here's a good one. Okay. This is from our Baker lab, Lab 4. Ooh, you know what? I think I'll have to use this as a source. 421. Let's see, where is me? I think I was right here. Students. Let's see. Yep, that's me. Ha 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 ha. You guys like that picture? Anyways, Lab 1. This is back when Dr. Baker used to teach the lab. So basically, our new 420 or our old 421 is our new 420. So I'm going to try and get you guys to design stuff. So we might, here's Lab 1, literally Lab 1, just installing and using Cadence. Maybe I might just even copy paste this for you guys. Wow. Jeez. So, okay, back to what I was talking about, lab reports. I want you guys making these lab reports for yourself, okay? I'll be honest, I forget a lot of things. I forget how to do the keybinds. I forget what the commands are. I forget everything. But when I look back at stuff like this, it gives me like the, whoa, I remember everything, okay? Because it'd suck if you forget how to use an $80,000 piece of software, all right? I want you guys creating these lab reports just for you, and then I'll sign off and be like, did you get your value out of that lab? Yes, no, maybe. So in the end, the rating is going to be very, very lenient in this class, okay? So the outcome of this class is based on your guys' performance. So if you put little effort, then you're going to get little effort out of here, and that's okay. I'm fine with that, but I want to make sure you guys get your money's worth out of this. So if you want to do like side projects, like design, like, I don't know, some cool like clock or whatever, be my very guest. You can, maybe even our final project might be just pick a cool project, simulate it, have fun, okay? And these are projects you can be worthy. So let me tell you this about industry, and I get this question asked a lot, especially I'm working with this, one of my best buddies. He's an IC analog designer for I think a good 10 years. Is his biggest complaint is that people aren't practicing cadence enough. And by practicing, he says, just mess around with the body effect of the transistor. Design, like, I don't know, some funny like telescopic op amp, or maybe a PLL, a phase lock loop, or something little cute. Just little circuits, okay? Just basically just investigate your own circuits. So you guys know how you can design circuits on LT Spice, correct? What's his name? That's kind of an example. Like, build some cool circuits. If I were to tell you, everyone design me like I don't know, some boost power supply or some, what do you call it, 10 megahertz clock circuit, right? You can research that, investigate that, correct? So that's like it sounds like not too difficult, but this is stuff that the industry is looking for. Do you actually know what to do? That's literally the question. All right, so it's not going to be like, oh, do you know the specific number of this transistor? And no, that's not how it works. It's basically, are you comfortable with using Cadence? Okay, so that's probably what our final project might be. It just might be just do something, something that you like, a project that you want to do. Like, I don't know. I think they were saying like a Schmidt trigger, or something really nice. Maybe a band gap. Let me see. Yeah, literally Lab 1. This is something I want you guys experiencing, creating like this little simple circuit. You know what? Maybe I'll link this. I think I'm going to link this, I'm going to link this. David Santiago's 421. Because let me show you what I did in my lab. See, we were following the Cadence design tutorials, but I think Dr. Mengzuz had his own stuff. What do you call it? Define tutorial 1. Check and save. There are 4 errors. Schematic check. Once you have the schematic done, you do your simulation. This right here is, Spectre. Yes, Spectre. Yes, this is the actual simulation thing. So you know how in LT Spice you do the simulation stuff, like the transients? Spectre is the application you're going to be using, okay? That's built in, so you can see that this right here is the voltage over time, half a volt, because it's a voltage divider, right? 10K voltage divider. Really simple, okay? Backing up work, please back up your work. MobaXterm is what we're going to be using, so all your work should be there. But I'd suggest backing up your work. So yeah, literally the first couple weeks, I need you guys learning how to use Cadence. So have you guys actually set up Cadence, your accounts? No? Did you get your accounts yet? Actually, did everyone get their accounts? Who hasn't had their account? Okay, he did? All right, so if you guys want to, you can log onto your computers. Has everyone done that? If you haven't, please log in. And we can probably go through MobaXterm. And then I think this lab might just be walkthrough. Anyways. And then I think I wrote a document too. Yeah, I'm literally going through the document he's going through. And then let's see. Has everyone gotten to this stage, right? Download MOBA or just got MOBA? Please get MOBA, please. And then after that, start your local term, okay? And then here's your command. Let me see if I can Control F. Settings. Let's see. I'll do that while I look something. MobaXterm font. Change font size. If you have a laptop, I highly suggest getting a mouse because a lot of the controls are literally in the fingertips of your hands. Okay, let's try this. Let me see if I'm still recording. Test, we are still recording. Actually, let me just test another thing. Okay, we are still recording there. Good. Okay, so it says I can use my scroll wheel. Okay, perfect. Can everyone see that a lot better? Is that good? Then you press enter, okay? This is our secure shell. Okay, and then I press no because personally, I'm trying to force myself to memorize every little detail. Don't want to forget your password. Here's Cadence, okay? And then let me see. I think what did he make you do? Did he make you do the actual like file thing? What do you call it? How to log onto Cadence? Or not log into Cadence, but like how to actually create directories? Yes, no? Okay, so if you look at my thing, let me just show you. Double click. If you do ls and then space and then the -al, you get this fat list right here. This is stuff that I've done in the past, so don't be scared about all this work. I have Cadence there. What else do I have? I have another proprietary file right here. This is a 180 nanometer process. This right here is the C5 process. And then, do I have? I don't think I have it. Let me just show you. So the folder I'm going to make you guys do in this class is make directory, or let me see. CD EE420 lab. Actually, let me just clear this out for now. CD. There we go. It's for this class. Can we let's make a directory called CD EE420 lab, okay? Or not CD. Using this command, make dir, right? EE420 lab. And then what did I have it as? S26, right? Can everyone do that for me? Just create a directory. This is going to be, it doesn't have to be exactly this, but if I, what do you call it? Copy, paste, or give you guys a file or a document, this is probably what I'm going to be using for this lab, okay? So create your directory. And then once you have that directory, all right, I use capital S26. Boom. And then let's ls. What do I have there? I have our 45 nanometer process. Okay, so we're gonna investigate this process. Okay, this is my first time too. I'm used to the other processes like our 180 nanometer. So this is a small process. Anyways, so the cool thing about our network here is that we have a shared folder. Have you guys talked about the shared folder yet? No? Okay, so we're going to talk about this, okay? So on your MobaXterms, you already have this. It's in a shared folder for the university. Our servers they're down this hall, and it's this big, like really loud room. You can probably hear it if you just keep walking down this hallway, but that's where we keep Cadence, okay? Anyways, if you want to get this package, type in CP, which is copy, share, apps, Cadence, libs. But if you're lazy like me, you can go here. I'm going to go to our root directory, okay? And I'm going to go to share. Let me see. Share, apps, Cadence. Whoa, okay, this is stuff I didn't think We have Pegasus? Oh gosh. We have a lot of things in here, y'all. Okay. So what am I downloading again? Let me see. What am I downloading? Libraries. Okay, Cadence libraries. We have a 45 nanometer process. We have a 90 nanometer process. We have the North Carolina State University. Oh, wow. You see, so here's the funny thing. I'm an IC designer by passion. And once you've been in this industry, you start seeing these light bulbs flash. Right now, it's not happening to you guys, so I'm going to try and guide you guys in a direction so you guys learn what's going on. But yeah, these are different processes, so we can, it would be nice if we can get TSMC's, like, I don't know, like 10 nanometer process, Intel's 5, and then we can design some cool chips. So point is, we're going to be using the 45 nanometer process, okay? And then let me see if I can show you. Yeah, is this a tar-zip? 2013, 2018, 2008. Okay. CDNS. Okay, right here. Is this right here? Version 6.0. Okay, if you copy this, copy file path, right? And then let's go back to your, what do you call it? Here. And if you do CP and then right click, there you go. I don't want to press this one. There you go. Let me just get rid of this right here. Does everyone see what I just did right there? How did I find those processes? So wink, wink, nudge, nudge. If you wanted to investigate these other, what do you call it, 45 nanometer, 90 nanometer, 180 nanometer processes, I'm telling you guys, we have this. But for now, I'm going to keep it one-to-one with the lecture, so we're not going to separate from what he's doing. So we're going to stick to the 45 nanometer process, okay? But we do have the 90 nanometer process and the 180 nanometer process. So we definitely have different processes that I didn't think we had, okay? So on your free time, if you want to investigate that, you only have this semester to do it, $80,000. Okay, be my very guest, all right? Anyways, once you've copied that, this is going to unzip. You should see a lot of files pop up, and then you get to the point where you see the following. Let me just do LSAL. You guys see this right now? Okay? So let me just see, because funny enough, I'm actually following a tutorial he's doing too. Let me see. Because I want to know how similar it is. Let me see. Files. Labs. There you go. What is this? Simulation? No, this is right here. This is what I've been following. Download. Let me just download this so I can do this from scratch. Okay. So literally the first lab we're doing is just even installing this like big machine. Okay. And then if you guys want to work on this at home, yes, you can. You just need to. I don't know if you need to do this, but you might have to contact the UNLV center or something like that to get the VPN. Who here has the UNLV VPN? How did you guys get it?
It's you can look it up. It's on the UNLV website, and they give you a full tutorial on how to install it.
We're gonna probably do that tutorial right now. Okay. This one right here, right?
I believe so. Click on it. Let me see.
Remote access.
Yes. Yeah. Fourth client. Yeah.
Because I don't want to use, okay, blah, 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 web campus, workday, no.
They have you download something called
For the client?
Inicia.
Oh, wait, which one?
So the fourth client is for the VPN, and then they do like a virtual machine thing called Omnicia Horizon. That's how you access your school account from home.
Okay.
Remotely.
So, not this right here, or. Oh, yeah, I remember this. Pulse Secure. Okay. I remember using Pulse Secure back in 2018. That's the other VPN I used. But now, it's 40 client now, right?
Yes. Yeah.
So download that one?
Yes.
Okay.
Yeah.
So I'm this is why I'm recording this. This is, and also this is our, if you treat this as our like a 400 like higher level class, this is where I'm happy to engage with you guys. We can talk about things, and since this is recorded for those who haven't showed up today, it's okay. They'll watch this at home, and for you guys to watch it again. Okay. Attendance is, I'll say this now. Is it mandatory? Not really, but honestly, I love engaging with you guys because right now, we're all dealing with this $80,000 piece of software. So I'd like for you guys to help me a lot. Okay, for those who can't make it to class, and I know I have a few graduate students that want to learn Cadence. They're learning from this at home right after I post this video. So this right here is our source. Okay, so this is the first time I think in UNLV that we're setting something up like this. Okay, so I appreciate your guys' help. Yes.
Well, yeah. So I wanted to ask. In the lecture, Dr. Zhu told us to set up MobaXterm and Cadence and all that. Do we need to be on a virtual
Like a VPN?
Yeah, like a VPN to the school?
In the school, no. If you are connected to EDU Roam, Edu Roam, or whatever they're calling it, you don't need to because you're on the network. You're connected directly to our servers. Okay.
But like if I'm at home and I'm not connected and I'm connected to my
So
home.
that's where I need you guys to investigate that.
Okay.
Run this exact same process at home, and if it's super slow, let me know, or maybe we'll make a Discord. I don't know. We'll think about something so that you may have to use the VPN to click into our network and then go into the servers. Yes.
Yeah, so last semester in 421, I accessed it perfectly fine without the VPN.
Without the VPN.
And it was actually faster for me at home.
Are you kidding me?
Yeah.
Oh, that's beautiful, because we had this problem where we just couldn't work without the VPN. Like things were like I don't know, 2 FPS. it was just sad.
But I'm assuming if you wanted to mess around with the other, other processes, that's
I don't think so. I think you should be fine. If they're saying that's okay, then I don't think we need the VPN, all right? So I think, let me know, okay? I want to hear your guys' feedback. Vote both Windows, Linux, and Mac users, okay? I want to make sure you guys are all up to date, okay? You can, yes, you can use this on Mac. Yes, you can also use this on Linux, but I'm showing you guys on Windows because I think that's like 60% of like all users or something like that. Okay, is that good with everybody? Anyways, let's see what else he has. Yes.
We're having trouble trying to log into what's this called again?
Log into this right here.
Yeah, MobaXterm.
Did you do the SSH client?
Well, we're on the part where like you try to sign in, by this page, I guess.
Let me see.
that file of
Huh?
That file is not in Cadence. We have to get it from the lab or 21.
They're trying to sign in, I guess.
Oh, the sign in?
Yeah.
I see what you're doing. So let's see, and that's why I'm trying to tie everything together. Let's go here. Let me see if I typed it. How to install Cadence using this guideline. So I do provide resources. Let's see. Does it tell you how to set this up? See, you get this. So you created a local client, correct? Like, or let me just do it again. If I do exit, okay, ls, and you did this command, correct?
No, I had not. I was following it's like a PDF
Or let me just do this
on
again.
on his what's it called, slide.
Okay.
Follow.
So did you do? So you got to this page, correct?
Yeah.
You press start local terminal, right?
No.
Or okay, no.
Press the session button.
Sessions?
Top left.
This right here? Oh no, this one.
Yeah. Well, just like a PDF, like how to.
SSH.
Yeah. It's the part like I'm not sure what to put in for a remote host or the username.
I don't think you need to.
Oh, no?
I don't think you do. Is that what you guys are being pushed to do?
No.
No?
Okay, so for you to sign in, just close that.
Literally close this one.
And then
Just start the terminal.
And that's it, yeah.
That's it.
Okay.
All right. What document did you get that from?
It's on his slides, like the first slides he has.
Dr. Zeus.
Yeah.
Huh? Y'all are yeah. Okay. Anyways, no. We're just that's why I'm creating a document as we speak. Anyways, can you do this?
Type it in.
Did everyone pass this part right here? Who didn't? Oh, you guys have?
Well, I haven't done it yet, but I see the thing that he's talking about. So Dr. Zoo links like an intro to MobaXterm tutorial for us, and it takes us to a website. And the process that it's telling us to do is the one he was talking about. Yeah.
Okay.
So go to lecture 0.
Lecture 0 right here.
Yeah. And then scroll down to like the second to last slide or something.
Okay, second to last slide.
Go up one. So then click on that first link. Or open, yeah. That's the one he wanted us to follow, but then it has us do like the thing that he was talking about.
Okay, open, run. Press session, okay. Pop up. Remote host. X11 forwarding. Let me try something. So if this is our remote, let me do something really wild. Okay. Just copy this. Oh. I want to do something crazy. Oh. Okay. Right there. Copy. Okay. Let me do something crazy. Okay. This might be funny. SSH. Remote host. Maybe this might work. I want to just test something. Let me see. Terminal settings. What does that tutorial say again? Your net ID. Okay. X11 forwarding. Is that it? Let's try that. X11 forwarding. And then I'm going to put my specify username. Santid4. Let's see what happens. I don't know. Sure. No. All right. So, anyways, this is why I enjoy education. I love teaching. I love engaging with you guys, students. So, there's two ways of doing it. Thank you. Thank you. Anyways, you can either do it that way. So, our host name is the CSIM, or what do you call it? What's it called? Whatever this thing is called. Yeah, csimcluster.ee.unlv.edu. That's our host. Your username is, well, your ACE account. Make sure X11's on. And then I think this may have solved a problem that I've had for a while. But anyways, I'm going to keep it running like this. Anyways, LS, because I wonder if this fixed the speed problem that I was having all the time. Anyways, does everyone understand what was going on there? All right? Maybe I'll put that in the document. Yes, I'm creating documents as we go.
You don't want to save a password, right?
Huh?
You don't want to save a password?
Personally, I wouldn't, because this keeps your muscle memory, all right? If you want to, be my very guest. But I have a preference that I try to memorize everything because I'm 28 and I'm already losing my memory a little bit. Am I the oldest or youngest or mid? Who's our oldest student? I don't know. Don't say any numbers. Who's UNC status? Who's over 30? Great. Anyways. Oh, it's okay. No worries. So yeah, is everyone shocked that I'm 28? I turned 28, I think, a month ago. Yeah, so pretty young. I'm about to start my PhD this fall, so that's what I'm gonna be practicing Cadence too, so I can use this on my PhD dissertation. And I think the core that I want to bring back, and Leo, we were talking to our partner Angshman. He's our industry partner, by the way. We're gonna try and bring back IC design. So I'm not trying to say it's just me. It's gonna be a group effort. Okay, so that's why we're working with him to bring something. I think we're even talking about doing a TSMC talk, so we can strengthen our core. This is modern technology. Any questions about that? All right. Thank you for the X11 thingy. So, all right, we got to LSAL. Or, oh, that worked too. Cool. We got to this point, right? Easy. So we also got to. Let me just do this. We also made a directory for our EE420 lab, capital S26. Yes. We also did our copy right here. Copy paste, right? We already did that, correct? Does everyone know exactly where we got that? Oh yeah, I see a picture. You see that? Is that good?
Yeah, thank you.
Do you guys want me to do it again, where I show you where it is?
As long as there's like a tutorial.
Yeah, let me see. I want to increase this font setting. Hold up. How do you increase not just the font setting, but I want to increase this font setting, not this one. Anyways. No. I want to zoom on this. Settings. Configuration. Not my terminal. Font size. I'm going to teach you guys something that's kind of maybe gut-wrenching, but bear with me. Let's see. Boom. Let me just, boom. Just going to copy this. And let's do something funny. Chat. Hey, chat. How do I increase the font size of these files? Because I don't have time right now. MobaXterm does not follow terminal zoom. Configuration. Settings, configuration, general. Here we go. Font or user interface. Font. You guys see font size? Toolbar. No. MISC. There is no font size here. Increase font size. Not the terminal. No, I don't want to do that. I don't want to change that anyways. If you want to get back to that page, do this. Okay? You can either just delete this bar right here, okay? Or you can just double click on this folder right here to get you to the top. Ooh, who's in this class? Anyways, not trying to expose. Who should I get into? Delete. Payson? I'm playing. I don't want to go into his folder. Anyways, double click on that top folder, and you get to this, the root directory. Okay, everyone following? Go to share. All right, applications or apps. We have 4 big fat applications: Cadence, Mentor, Synopsys. And, well, this is, I don't know what this one, I feel like it should be Synopsys, but yeah, Synopsys. But we're using Cadence. Look at all these cool files, okay? We're going to go to libraries, okay? Here's our processes, but we're going to go into CDNS. And right here is it's called GPDK045_V_6_0.tar.gz. Okay? Is that clear with everybody? I wonder. Try something funny. Oh. Yeah, you can download this too. Be my very guest. But we're not trying to download this. We're trying to copy this within. Right now I'm doing like a hardware download. Don't do that unless you want to really back things up for future investigations. Wink, wink, nudge, nudge. Right click on this. Copy file path to terminal. No, I don't want that. Okay. In our EE420 lab, S26, okay? I'm going to right click on this. Copy file path, correct? I'm going to type in CP, and then I'm going to do a right mouse click, or I think you can do Control V. No, you can't do Control V. Right mouse click, okay? And then you press enter after that, okay? And then you get the file, okay? Is that good with everybody? Any questions? No questions? Anyways, now that you have that, the next step is to actually unzip it, okay? Extract it. Let me see. Do I have an I don't have an extract button. Where is it? There it is. tar. So we're gonna be using. We're gonna be unzipping this. tar -- strip components right here, right? And then we're going to have all these other commands. And then don't forget the period. If you see there's a period right here, right? Don't forget that period. That's important. Okay? Don't tell me why. I don't know either. Anyways. Did everyone get to this point? Yes? Who didn't? Huh? This one right here. So you can access this one in Dr. Zhu's lecture, but I'm just copy pasting it, but I'm editing it for the purpose of this. All right, is that good with everybody? So I'll be uploading the best that I can with this. So by the end of today, we're gonna do something similar. All right. Any questions about that? And then after you do your tar, okay, you're gonna see some crazy stuff just pop up. Okay. Did everyone see that? Who didn't? Cool. After that, do ls space dash or ls space what do you call it? This little hyphen al, and you see all this cool stuff. Did we get to that point? Okay. Now the next thing, Dr. Zhu does the following, but I don't like the terminal. Let me see what he does. Let me see. Let me see. He makes you use the Nano application, but I don't like Nano. I'm a Get It person. So if you want to do this, type in Get It, okay? And you should get this following window. Then it pops up. And boom. Bear with me because this is... Oh no, it's so small. So small. But anyways, initially you're not going to have something like this. Oh, that's so tiny. I don't like this. Let's see. Anyways, let me just show you the document that I copy pasted. So you should see something like this. Okay, did you guys see that? Yes? Anyways, this define thing is our this analog library is where you're going to have your voltage supply, your resistors, all your basic components, or I think that's what it is. Basic is another library. These are all libraries just for simulation, okay? So they're basically mathematical models that you can use to simulate your inverter, for example, okay? So this is what you're going to have by default, okay? But we're going to be deleting this, all of it, including this space up here. I think you can use dashes, yeah. And then you can copy the following, okay? Does everyone know how to copy? Do you want to type all that, or no? Let me see. Because everyone here has access to his lecture, correct? Let me show you. Oh, you don't? You don't?
I'm not in.
Oh, so you've taken
I took it with Gavala.
Gavala.
Yeah,
Okay. So you're okay. That's a good thing to know. Anyways, copy. Let's go to home. Let's go down here. Boom. Let's make a, I don't know, announcement. EE420L CDS dot lib text file. Is that good with everybody? Publish. Wait, is this the right class? Lab. Okay. Is that good with you? So now you guys can copy paste that. Anyways. And then after that, I didn't finish that part, but let me see what's next. So now your file should look like that. To just save, hit Control X. I just do Control S, save that. Not too bad. Create a file. Okay. So the next thing we're going to do is create a file. Let me show you this. Ugh. There we go. Unscroll. I'm going to do the following. Get it. Dot CDS init. Okay. Create this. Oh, hold up. Okay. Init. Let it run. Oh God, I don't want to do this. Okay, let's try it. Okay, let's try the nano one. Nano.cds init. Okay, that's fine. Whatever. And he says to copy all this. Okay. Let's just type it out. Enter. This is CDS init EE420 S26 setup. Okay. This again. Then always load cds.lib from this folder. Okay. So now our first command is going to be environment env set val CDS libpath and string, okay, apostrophe string get working dear inside parentheses 1 2. Is that good with everybody? Yes? See if I can scroll in. Okay, there we go. Next line is going to be our default simulator environment set value asim environment dot startup, and then simulator string we're calling Spectre. Spectre is our simulator, okay? So this is how to set up the simulator. Okay, cool. And then print configuration. Print f info loaded .cds init from what do you call it? %sign s /n boom get working dear. This. Did everyone get that part? Yes?
Sorry, did you say you're recording this?
Yes, I am recording this. Okay. So, yeah, go ahead. All right, take care. Yeah, if you have something going on, just let me know, or just go ahead, do your things. But anyways, yes, I am recording this, so you guys can go over this. Maybe I'll try to see if I can do a channel thing or use some AI video folders, whatever it is. Anyways, everyone got to this point? Yes? Oh.
Was that PDF posted? Or are you gonna post that?
Should I post it? You know what? I'm going to post this actual PDF. Everyone's complaining.
Are we supposed to access that PDF through MobaXterm?
MOBA? Oh, the actual one, like this one right here? This one is actually from Dr. Zhu's course. So you know what? Because I'm too crazy about this, let me just do the following. I'm gonna do Dr. Zhu's stuff module. Where did I have that? 420 guide. Boom. Publish. You guys getting that notification? So now you guys can just copy paste it. All right. So if you want to copy paste it, just go here and just copy paste. Don't type it out. Okay, I'm too lazy to, but I don't want you guys suffering. This lab is already too hard as it should be. Any questions from there? No? We're all good? Anyways, to save, just hit Control X, okay. Control X. Save modified buffer. Y, and then enter. Oh, cool, okay. Now you should be able to launch Virtuoso. All right, this is our final stage, okay? And then maybe, honestly, I'll let you guys do the rest for homework. Is that good? Okay. So, did everyone get to this stage of actually setting up that .cds init? Okay? This is very important because if you don't set this up, the whole rest of this course, the lab course and the theory course, the actual lecture is going to hurt. Because I don't want you, because learning transistors is already hard. I don't want learning the software to also be hard too, okay? I want to make this smooth like butter, okay? Any questions? All right, now. Ooh, I'm excited, y'all. Anyways, we are in our lecture, or in our lab folder, correct? Is that good with everybody? The EE420 lab _ S26. Yes? Is everyone there? Is no one there? Or is someone not there? Okay. Let's do the following. Type in virtuoso space ampersand and watch the magic. Oh, beautiful. It's going fast. Maybe I had something not set up. This is the fastest it's ever loaded. And then you should see this little pop-up. Cool, right?
Is that error matter? Is that error there?
It's called error eval. Eval is not a function. Get working dir. GPDK does not exist. .420 lab. Oh! I typed in something wrong. Let's see. Let me just cancel, okay? Do you wish to quit? Yes. Oh, yes, what's up?
I remember last year you had an error somewhere in the doc. You had the expiration after one.
Okay, let me see, because I think I know what my error is. I have an S, extra S somewhere. Oh, there it is. S, 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 okay. Let me show you, okay. EE421 lab, not labs. You see how painful this application can be if you don't know what's going on? I'm going to copy this again. I'm going to paste this so you guys can have this, okay? Copy. Okay, Control S. Copy. Announcements. And then, no, I'm not going to do that. I'm going to do add announcement. Correction. cds.lib file. There we go. So you guys are going to get the error, okay? If you don't change that. So lab, not labs. Publish, okay? So now Control S, exit. And then let me just check my nano. Okay, 420. 420L. Okay. Let me just 420 lab. There we go. That's how I had it. Let me just see. Control X. Yes. Enter. Okay, 420 lab, not 420L. Underscore S26. Let me just do the nano again. Okay, get working directory. Boom, boom, boom. Okay, can I press enter again? Nope, I cannot. Okay, Control X. Yes, enter. Okay. Now let's run Virtuoso. Okay, come on. Okay, we're running. Yep, this is super fast. Okay. S26. Is anyone seeing what I'm seeing? Let's see. Let's see if I can. Let's see. 420 lab. Boom, boom, boom. cds.lib. See. 420 lab. Boom, 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 boom. Not a function. Are you guys getting this error too?
Yeah, we're not there yet. So.
You're not there yet? Let me just check something. Because if we don't set this up correctly, then there's no point in going forward. Okay, Control C. Let's do get it. cds.lib. Okay. cds.lib E421 lab S26 setup. Define GPDK 045 or 045 EE420 lab S26. Okay. Define this guy. Yep. That looks good. Let me see. Something might be wrong. Check this. Oh, SVTAL, SVTAL. Oh, I made another mistake. Or did I? No, I did not. Okay. SVTAL, SVTAL, GPlib, GPlib, GSSib. Okay, we're good. EE420 Lab S26. EE420 Lab S26. I'm getting the right names, correct? Let me see. EE420 Lab. Let's look at Nano again. CDS init. EE420 Lab S26. Get working directory. Default simulator. Get working directory. Everyone's getting this part, right? Anyways, Control X. There we go. And virtuoso. Virtuoso ampersand. Maybe something else is going on, but I'll get to you guys when I can. Anyways, yeah, that's concerning me right here. Let me just copy and paste what I see, okay? You know what? Let's investigate this, okay? Because I don't want to look at this. Control C, Word, blank document, paste. It says our first warning, cannot find virtual pin size. Cannot find, okay, these are just warnings. Don't worry about that. Loading these, okay. Okay, that's me. E420 lab S26 cds.lib. Why is it skipping? Skipping cds.lib. Okay. Skipping data. Skipping GDPK. What? Is anyone understanding what's going on? Does not exist, but was defined in lib file home. Okay. So it's saying this doesn't exist, but was defined here. Okay. Maybe I'll have to come back with this next time. So it's saying this doesn't exist. Let's check that because I don't believe it. Control C. LSAL. Okay. GPDK. There it is. CD GPDK 45. Okay. GSSib. Okay. Oh, you're right. It's not there. Does not exist, but was defined here. Okay. Let's see if we can figure this out. Nano cds.lib. That's not right. Something's wrong here. Hey, someone was mentioning there was an edit. Is this something he edited?
No.
No, he did not edit this.
I don't remember what it was, but he just give me the file.
Okay. So this is correct. It's defining this one, but it's saying this doesn't exist. GPlib. Let me show you what's going on. Okay, Control X. CD GPDK LSAL. Okay. Cadence. Yes.
This is what last year's looked like.
last year's look like? And that worked?
Yeah.
Analog lib, fall, EE421, GPDK. So I did something wrong where it didn't download. You have these libraries, the GP lib,
Yeah.
and you didn't get that error? Interesting. Let's see. Yeah, if you can, because that's I'm trying to figure out that problem so everyone here can understand what's going on too. Anyways, ls al cd ls al. So we're gonna have to find that library, but anyways, unless I want to do something funny, td underscore ls al. Let's do make dir ee test or whatever. Let me see, 421. Do I want to do that? L F20 F25. Let's try that. Then let's go back to. Let's try that. Give me a second, y'all. It's not giving it to me. Anyways. There it is. CP. Where's CP? Hold up. CD, CP. Hold up. Okay, anyways. Yeah, let me see what you got.
These are all meter. I got some.
Oh!
It's fine.
What are we doing, everybody? LS. Okay. No, thank you for that. Why was I focusing on that? EE420 lab. Virtuoso. But I have to investigate that problem because I don't want that to go crazy with everybody. Okay? Anyways. Oh, I've already ran it. Ugh. Anyways. Exit. Yes. Exit. I'm telling you, this is a headache. Okay. Anyways. Enter. Run Virtuoso again. Ampersand, okay? And then I just want to show you this next part, okay? If we can get this part, then honestly, I'm calling it a victory for today. Okay? Go to File, or not File, Tools, and go to Library Manager, okay? Don't worry about those errors, okay? There we go. So I guess we're going to have to exist with the errors. It's okay. No worries. Anyways. And I think what I want everyone to do right now is we're going to create a file. New. Library. Okay? And call this one my, I don't know, library. My library or whatever. There you go. And then let me see if it's going to let me. Want to know if it'll let me put in a process on it. Design manager. Yeah, sure. Okay. And then we're going to attach to an existing technology. Okay. Hopefully it lets me do that. And we're going to attach to the GPDK 045. Okay. Is that good? And then congratulations, you have your new My Library. Is that good with everybody? Double click on it, or I think it's already there. Click on Cell, and let's create a file, New, Cell View, okay? Let's call this one NMOS. Yeah, call this one NMOS, or My NMOS. Okay, this is going to be a schematic. Let me see, which one should I use? Schematic, there we go. Then don't worry about schematic L. We're just going to keep it there, okay? Run it. Is that good with everybody? Congratulations, we made it. Is that good with everybody? Any questions? Let's type in I. I think I is the button. Add instance, okay? Now I want to do something really, really basic, okay? So we're going to add an instance, and this instance is going to be from our GPDK library, okay? We're going to add, let's see, which NMOS should we use? Oh gosh, there's a lot of things in here. Let's use this 1 volt underscore 3. Let's see what it does. No, I don't like that one. NMOS 1 volt. There we go. Let's use this one. Okay. Can I change the fingers on this one? No, it won't. That sucks. HVT. 2 volt. Yeah, it won't let me change the fingers. Okay, we won't be designing that crazy, but I want to show you guys anyways. Let's just let's instantiate that. Body type, boom, 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 boom. Let's hide. Okay, click that right there. Does everyone see that right there? Is that cool? Anyways, let's press I again to create an instance. Let's create a PMOS right here. Let's see, PMOS 1 volt. And that you can change. Okay. Huh? That makes me mad. Anyways. 45 nanometers, 120. Yeah, that's fine. Okay it. Boom. Is that good with everybody? Everyone got there? Then press W for wire. Click, 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 click. Yeah? Let's click up here. Boom. Let's W again. Click right here. Boom. You can double click too. There we go. Then I'm going to click here. Bring that out here. Bring that out here. Bring that out there. Double click again. Here. Click. Double click, or let me double click there, click and bring that there. Is that good? Did everyone get to this point? Yes? What's up?
How do you go from that library tab to that?
Do this right here.
Yeah.
Go to your, let's see, called. So you got to this one right here, right?
Yeah.
So you go here, you click on this box right here, create file, new, cell view. All right. I don't know why I'm calling this my NMOS. I should be calling this my inverter. Okay?
Where did you create again?
Huh?
Where did you create?
File, new, cell view. Is that good?
It's like blurred out for me. I can't click cell view.
Did you create your my library? Did you create my library? So did you create file, new, library? Right? And then I'm calling this one some library, some lib, whatever, right? And you press OK. Attach an existing technology library. Are we getting there? Cool. Okay it. Then we select the GPDK 045. Yes? Okay it. Then it creates a new library. You should see that on this side. Right here. This is some library. Is that good? Then go to your library. Should be creating just an N, like a, what do you call it, NMOS, but anyways, because I'm jumping ahead. I'm gonna create a file, new, cell view. Let's call it my inverter. Okay? And then the type, you're creating a schematic, okay? Click schematic and then press OK. Okay? So suppose you have two schematics, okay? This is a good one too. How do I copy one schematic to another schematic? Press F to do this type of zoom, okay? You can hold this, Control C. I think it's Control C? No. Yeah, copy. Let's see. Yeah, copy. Hide. Is it not gonna let me move it? Oh, okay, there you go. So let me show you how I did that, okay? I'm gonna hold all this. I'm gonna press C to copy. Click on your actual schematic, okay? Now you can copy this anywhere, including to another schematic, okay? Paste, okay? This right here is called my inverter, okay? This one here is my NMOS. So I think for this demonstration, let's just delete this right there, okay? Boom. And then let's boom, boom. And yeah, let's just delete that. Has everyone got that right there? This is my NMOS. This is my inverter. Not too bad, right? Good? Everyone following with me? Anyways, the next thing I want to show you, and then let me see. Look, I'm going to Control S this one, okay? Check and save. There are 10 warnings. Don't worry about that. I'll show you that later. I'm going to exit out of that one. Okay, is that good with everybody? If you press P for pin, you can create a pin. I'm going to call this one my gate. Hide. Boom. Pin. I call this one my body. Let's see. Body. It is an input output, okay? Is that good with everybody? Does everyone see this cool little symbol right there? Yeah? Click right here. And then honestly, let me just see if I can mirror this. S to stretch. M to move. M to move. There you go. Is that good with everybody? S to stretch. Oh. Hold up. Come on. Control Z. Control. Can I press the U button for undo? Move. Boom. Can I just carry this thing? There you go. There you go. U to undo. Anyways, create the other one. Let's call this one the drain as an input output. And this one is going to be our source. Is everyone good with that one? Okay? Everyone cool? Let's control. There's a button right here called check and save. So it's going to verify that you actually did this correctly, okay? And then you'll see your window and it said schematic check complete with no errors. Is that good with everybody? Yes? Who's ready to simulate this? Okay? So, should I make the gate? If you want to re-edit something, right click on it, properties. You can change the properties of your pins. So I'm going to change this to back to an input output, okay? Because technically things can come out of your gates. It's weird to say that, but it happens. Is that understood there, everybody? Cool? Control S or this right here. I don't think there's a hotkey for that one, okay? Anyways, we happy with that? So let's go exit out of here, okay? I want everyone to do this following, and I want everyone to do this kind of procedure. It makes it your life a lot easier, okay? So let's create a, what do you call it? New. Oh, come on. Uh-oh. New cell view, okay? We're simulating my NMOS, right? So I'm going to tell you guys to do this. Could you do the following? Type in sim, S-I-M, underscore the actual file name. All right, this keeps everything organized, so everything is like one-to-one, all right? Is that good? So now we have a new schematic here, and this is where we're going to simulate our actual NMOS. But before we do that, let's go back to my NMOS because I'm forgetting one more thing. I need to show you this. We need to create a, what do you call it? Cell view from cell view. We're going to create a symbol. Is everyone clear with that? Does everyone understand what I'm doing? Yes? What up? Oh, you're good? So how did I do that? Here's my NMOS, correct, right? I'm going to create, right here, there's a button called create on the top. Cell view, I'm creating a new cell view, correct? From this cell view, okay? Click. This is my NMOS, right? And I'm going to create a symbol, okay? It's already done that by default, okay? Okay it. And then it says left pin, right pin, top pin, bottom pin. So I'm going to put the left pin as my gate. So I can delete that there. Put gate. Right pin, I'm going to put body. Oh, I can't even type body. Oh, come on. This is what I'm talking about with Cadence being funny. By the way, please be saving this because there's a chance Cadence can crash. I think... Woo! 1 for 1, everybody. Yep, Cadence crashed on me. Anyways. No. Yes, Cadence will crash on you and you will lose all your data if you don't save. There's no other thing I can say. So anyways, CD EE420 Lab, Virtuoso. I don't have that command. Let me just type it in. It could also be that everyone's on the same server too. Okay, there we go. Yeah, I just want everyone to look at this, and then I think maybe your homework assignment literally is just going to be to simulate an inverter. So I'm literally doing your guys' lab. Anyways. Library manager. Here's my library. My inverter. Okay. Or not inverter, sorry. My NMOS. Oh no. Oh no. Okay. Oh no. Oh no. Okay. So here's another drastic error, and this is why Cadence is really, really funny. So let me just show you what I'm going to do, because this is a very, very dangerous thing to experience. So let me exit out of Cadence, okay? If you need to do this, okay, it's going to happen. Okay, let's go to your EE421 lab or 420 lab. Okay, let it run. Oh, it's gonna crash. Don't crash, please. Yeah, that's my fear with this class. I'm on. I'm on. Reconnect. Whoa. Why is it not reconnecting? I think it really crashed. There we go. Okay. Oh, it crashed anyways. Whatever. There we go. No. There we go. I'm trying to show you guys what's going on. Let me see. E420 lab. Why won't it let me? Ugh. CD EE420 lab. Okay. LS AL. Okay. We need to go right into that library. CD my library. Okay. LS AL. Okay. Go into CD my NMOS. Okay. LS AL. Go into CD schematic. LS AL. There it is. So we need to remove SHOA.CDS lock, okay? We're going to remove two things. We're going to remove the lock and the other user lock. That's pretty funny. So let's delete the user lock, csim. Oh, it's not letting me. Whatever. csim cluster.ee.unlv.edu.24083. No such. How do you delete a file? Linux delete file. Which command is that? Is it rm? Yeah, literally rm. Okay, no such file or directory. Let's just delete this lock. There we go, it worked. Now LSAL. I think that should work. rmchs.oa.csh. There we go. If you remove those two locks, okay, we're gonna run. Okay, cd dot dot cd dot dot cd dot dot. Okay, this is our home directory EE420 lab. Okay, virtuoso ampersand. So if a crash or virtuoso ampersand. There we go. So how to fix it when your computer crashes or MOBA crashes and you can't access your locks or your file says it's locked forever. And yes, it does happen. So that's how you fix it, okay? Any questions about that? I think it's because a lot of us are on the server right now. I've been telling them to upgrade it. Anyways, tools. Library manager. My library, my NMOS. I can finally open it. Is that good with everybody? Okay. It creates a lock. Because I want to simulate this and then that's going to be the end and then I'm going to make you guys do your inverters, okay? Come on, laggy server. Okay. Create. Cell view. From cell view. A symbol. Okay. I'm going to do this gate. My right pin is going to be my body. My top pin is going to be my drain. My bottom pin is going to be my source. Okay. And okay it. Now let that do its thing while it's still working. Please don't crash. Boom. You like that? And then we can draw, you can draw I don't want to show you guys this because this is another application. This is our symbol editor where you can draw the NMOS, but right now I don't have that time, okay? So you like that? That's our NMOS, okay? Cute, right? Control S. So, or not Control S, just check and save, okay? We'll do the design later, okay? You can figure that out for your homework. I'll give you guys some sources. Anyways, oh, come on. There we go. Let's go back to sim my NMOS, okay? Which also has a lock. You kidding me? Let me see if I can brute force this. While you're still on Cadence, CD, what do you call it? My library, LSAL, okay? CD sim, okay? LSAL, CD schematic, okay? LSAL, RM, remove, SCH, OA, .cds.lock. Let's remove that lock, okay? Then remove the other one. Okay. Is that good with everybody? Now let's go back into our library manager. Let's refresh it by just going somewhere else. Boom, we can unlock it. Woo! Is that good with everybody? You see how this is all this lab is just dealing with Cadence. So are you guys comfortable hearing that? I'm not gonna make you design like a 4-stage amplifier in Cadence and you're like, I don't even know how to get past the virtuoso part. I know this lab's gonna be tough, and this is the whole point of this course, okay? Anyways, now that you have your sim, okay, press I. Just press I. And we're gonna add an instance, okay? Go to your library, which is called My Library, okay? Click on it. You're gonna go to your cell. Come on. My NMOS, okay, there it is. My NMOS, okay. Hide. And boom. You guys like that? It's your NMOS. It's kind of ugly, huh? Anyways, we're going to do some cool stuff right now. Create an instance. We're going to go to the analog, or is it basic? Let's go to basic, okay? I want to look at some stuff. Let's create a ground symbol. Oh, come on, you dumb. Come on. GND. There we go. GND. Hide. Let's put it right there. Let's create another instance. Call this one VDD. Right? You see. No, not VDD. Let's go to analog library, sorry. V pulse. Let's see. Oh. Let me see if there's a. I'll have to revisit this. VDC. I think this is it. Yep, there it is. There we go. Ground this. Boom. Wire. Boom. Boom. Wire. Boom. Okay. Copy paste this. Boom. 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 It's literally LT Spice, but just different colors. And then I think I'm just going to show you this right now. The body of the transistor is also going to be grounded too. It's usually connected like this. All right. This is a source body connected NMOS. Everyone good with what I'm trying to do? All right. And then because I'm lazy, copy, boom, paste, boom. Okay. Boom, boom. Is that good with everybody? And then let me just see if I can double click. Hold up. Whoa, 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 whoa. It's supposed to pop up something. Hold up. Because then I'll have to complain too. V. Let's see. VDC. I don't want to do V pulse right now. Let me just check this one. Hide. This is what's supposed to pop up for this guy, but let me just see. DC voltage. Yeah, that's funny. That's our pulse, okay. Let me just get this for you because I'm not liking this. V. Let's look at our other V source. VSS V source. Ugh. Is this it? What the heck is this? Give me a second, y'all, because I don't want to cheat y'all of your education. VSS, VSIM, VPulse, VPNP. Because the right source is this one, but it's not giving it to me, so I'm going to investigate this later. Okay, anyways. Now it does it. This is so dumb. We're going to do 1 volt, okay? Hide. Why? You see, this is what it was supposed to do. Press P. No, it doesn't do that. Press O. No. Right click. Properties. Anyways, to this V source, okay? What is that command? Q. Press Q to go to properties. Okay? Do 1 volt. Okay? Delete this. Delete this. Delete this. Or keep that one. Q. Let's do yeah, let's do 3 volts, whatever. Okay, is that good with everybody? Check and save. Whew. All good? We got Pegasus. Open run. I've never used Pegasus before, but let's see what happens. Whoa. Open run manager. Let's go check what Dr. Zoo has. Let me see if he has anything else. I think for now, I'm okay with this, okay? Is this a good stopping point for everyone? Everyone good with going home? Alright, so I'm going to try and figure this stuff out too. Honestly, the due dates aren't going to be too bad. I'll give you guys some lenient time. This is the hardest part. Better yet, now that you guys know how to instantiate stuff, I think for homework, if you want to do this on your own, learn how to design your own symbol, like create the NMOS symbol, investigate the symbol editor, the schematic editor, and then I'll get back to you when I can get the simulator running, okay? Is that good with everybody? All right, any questions? Have a good day, everyone.